Okay, so same instructions. We are solving for the angle to be between 0 and 2 pi. Notice where the equal to is. It is with the 0. So if your answer is on the x-axis, then you use 0 for the answer, not 2 pi. It's the same angle. Right? It's just a little technicality in what we need to include. All right, so these equations look a little bit different than the ones we previously did. We've got more numbers involved in the equation. In this case, we have a coefficient in front of the cosine of theta. Well, we are solving for theta. Theta is in the trig function. The trig function is not alone, so it's just like all the other equations that you've ever learned how to solve. You want to try and isolate that expression. So right now it's being multiplied by a -2, so we need to divide both sides by -2. So cosine of theta is equal to 2 divided by -2 is -1. Okay, cosine is our x-coordinate, so we go to our unit circle and we look for an x-coordinate of -1. There's only one place where that occurs, and that is at pi. So this one only has one solution. And we can check it just like we checked the first examples there. -2 cosine of pi. Go back to the original equation. Okay, don't plug it into any of your intermediate steps. You got to go back to the very original to confirm that the left side's equal to the right side. So the majority of the time you're going to have multiple answers, but sometimes you do just have one. Okay. All right, another example. Let's look at one involving sine. 2 minus the sine of theta is equal to 3/2. So this one's a little different than the first one. It's not a coefficient in front of the trig function. We are actually adding 2 to the negative sign. So we need to start by subtracting the 2 from both sides. 3/2 minus 2 would be -1/2. Use your calculator if you need to. Trig function still not by itself. It's got a negative in front of it, so we need to divide by -1 or multiply by -1. Either way you want to look at it. -1/2 divided by -1 makes that a +1/2. So sine of theta is equal to +1/2. So sine is our y-coordinate. So we go to the unit circle. We're looking for a y-coordinate of +1/2. Again, don't kill yourself. Think about it first. Positive y's were only in the first or the second quadrant. So positive y value of 1/2 is at pi/6, and it's at 5 pi/6. So theta equals pi/6 and 5 pi/6. Again, you can confirm it. 2 minus the sine of, let me do the 5 pi/6. I always do the first one. We'll check the second one. Equals 1.5. 3/2 is equal to 1.5. Okay, let's do one with tangent. -1 plus tangent of theta is equal to -√3 minus 1. -1 plus the tangent of theta is equal to -√3 minus 1. So again, trig function, not by itself. Start by isolating it. So in this case, we've got that -1 in front, so let's add 1 to both sides. So we have the tangent of theta is equal to -1 plus 1. Cancels on both sides here. Usually that doesn't happen, but it does here. So it's just equal to the -√3. So tangent is our y over our x. Hopefully you're getting used to the tangent values as well. So we need to put the y over the x and end up with just the √3. So I'm thinking 60 degrees. If we put the y over the x and we flip and multiply, we do end up with the √3. If you do not already have that written on your unit circle, put it on your unit circle. But what do we need? We need a negative. Okay, so we're looking for pi over 3, but we need one positive, one negative. So that's going to be 2 pi over 3 and 5 pi over 3. And again, while y'all are writing that down, I'm going to check it real quick. -1 plus the tangent of 5 pi over 3 gives us a crazy little decimal value. Check the negative square root of 3. You have to close your parentheses because the -1 is not in that square root. Confirms that we get the same value on the left side as well as the right side of that equation. All right, couple more. So again, 5 sine of theta is equal to -1 plus 3 sine of theta. Now we have trig functions on both sides of the equation. It's just like related to variables, y'all. This is just like the equation 5x is equal to -1 plus 3x. Just replace the trig function with the variable. Okay? How would you solve that? You got variables on both sides. You want to get the variable on one side. So we would subtract 3x, and then we've got it on one side, so then we divide by 2. Well, guess what? Bless you. It goes exactly the same way. We got trig functions on both sides. The trig functions have our variable in them, so we need to move that to one side. And just like an x, the sine of theta doesn't go away if you subtract it. You just subtract the coefficient that's in front. We've got 5 sines of theta, and we have 3 sines of theta that we're taking away from it, so we still have 2 sines of theta. They don't cancel. We just have 3 fewer than we had before, so now we have 2. And then we're multiplying by 2, so we want to divide by 2. Sine of theta is equal to -1/2. So sine is our y-coordinate. We go to the unit circle. We want a y-coordinate of -1/2. That only occurs in the third and the fourth quadrants at 7 pi over 6 and 11 pi over 6. And I could check that one. I will check that one while you're finishing up. Okay, plug it into the left side. 7 pi over 6. Plug it into the left side. Plug it into the right side. And make sure that they agree. Almost identical problem here, just involving tangent. 5 tangent of theta is equal to -2 plus 3 tangent of theta. Again, trig functions on both sides. We want to make sure it's only on one side. So, same case as before. This time we just have tangents. We had 5 tangents minus 3 tangents gives us 2 tangents. I haven't really mentioned this up to this point, but yes, you need to always put that theta. Don't get lazy. You have to put the variable because trig functions don't mean anything if they don't have an angle. If you just write tangent, if you just write tan on your paper, you're not talking about a trig function. You're talking about what you get in the summer when you get, out in the sun a whole lot. You got to make sure that you put the variable with the trig function. It means nothing on its own. All right, so we divide both sides by 2, so we get tangent of theta is equal to -1. So our x and our y coordinates have to be the same, but with opposite signs. So that's at our pi over 4 angles. Negative and a positive is at 3 pi over 4. Positive and a negative is at 7 pi over 4. So 3 pi over 4 and 7 pi over 4 are our answers there.